Hi, this is Trisha again from Product Labs, and this is session number 8, ribs and rounds. Why do we create ribs and rounds in the parts? How do they help in the design? These are some of the questions arises in our mind when we talk about these topics. So I'm here to help you with some of the answers. First, ribs offer additional strength to the parts without increasing cross-section thickness. This helps to reduce the part weight and cost. Second, rounds and chamfers eliminate sharp edges and corners, therefore help to eliminate safety issues. Third, rounds are very useful to reduce buildup stresses in the parts. So session 8 on ribs and rounds next in this series.
First, open a solid model which can be used to make chamfers. Click on the chamfer button. You can see there are two options, edge chamfer and corner chamfer. Select the edge chamfer option from drop-down. Now, select the edge to be chamfered. Chamfer dimension can be changed from here. Change the model orientation to front view. In the drop-down menu here, there are multiple options to create chamfer. What we opted just now was D into D option, which means distances on both sides are equal and value of D can be entered in the field provided in the top left side. Now, we'll choose the option D1 into D2, which means distances are different on both sides. Values of D1 and D2 can be entered in the respective fields in the top left corner. Now, we'll go for the next option, which is angle into D. We can input the angle and distance here at the top. We can vary the angle like this also. Next option is 45 into D, which means angle is predefined at 45 degrees and we can change only the distance keeping the angle constant at 45 degrees. Notice the change in the value of D here. Now, let us learn the application of sets. Select the three edges one after another. Remember to press Ctrl button to select more than one edge. Before we click on fourth edge, we have to check Created Sets under the tab Sets. Here, you can see set 1 is already created, which has 3 edges within it. Now, we'll create another set called as set 2. And select the fourth edge, which becomes the part of set 2. Now, click on OK button. Press Ctrl plus D to fit the model in the window. If we edit the chamfer dimension of any of the edge in set 1, all three chamfer will be updated simultaneously. And if we edit the dimension of fourth edge, which is part of set 2, then only fourth edge will be updated as there is only one edge in set 2. So, sets are useful when we need to chamfer more than one edge. Now, let's delete the edge chamfer to proceed for corner chamfer. To do this, right-click on the feature to be deleted and hold and select Delete option from pop-up menu. Select the corner chamfer option from top menu bar. Select a corner to be chamfered. As you can see, we need to define 3 dimensions D1, D2 and D3 for corner chamfer. Enter the values of D1, D2 and D3 in the respective fields. Dimension adjustment can be done by pulling these points also. Click OK and press Ctrl+D to fit the model into screen. Now, delete this chamfer. Now, we'll be learning to create different kind of rounds. Click on the button labeled as Round in the top menu bar. There are 2 options to choose from in the drop-down. First, we'll use Round option. Next, click on the edge to be rounded. Round dimension can be changed by clicking here. Change the model orientation as front view. So, this is basic circular round. Now, click on Sets and change the display style to No Hidden for better visibility. Click on the drop-down menu here and select the option Conic. Now, we can define conic parameters at the top menu area in the respective fields. That's all about conic style of round. Next, we'll move on to C2 continuous round. Let's select C2 continuous option from drop-down menu at top. Again, C2 shape factors parameter fields appear at the top in the menu bar area, which can be modified as per need. With this, C2 continuous option is done. Let's try D1 into D2 conic option now. Conic parameters entry fields can be seen at the top, which can again be modified as needed. In the same fashion, we can do the last type of round, which is D1 into D2 C2. In this kind of round, spline cross-section is used with independent distances. Now, let's go back to circular type round and change the model display to solid. Press Ctrl+D and click on OK at the top. Now, we'll learn to create round with more than one radius at a time in a single feature. Right-click anywhere in the graphical window area and select the Edit mode in the menu. Click back on Sets tab. You can see the current radius of round is being displayed in the window at the bottom. To add another radius, right-click here in the radius area, which gives an option to add another radius. Along with radius, we can see the location option is also populated next to it. Now, we can change the radius at both the vertices. Now you can see that the round shown is having 2 different radius. If we want, we can add third radius as well in the same manner. You can play with the radius values to get your desired shape. Now, click on OK to finish this operation. Now, we'll delete this round to proceed for next operation. We can do this by right-clicking and choosing the option Delete from the pop-up menu. Now we are going to learn as how to use sets in case of rounds. Once again, click on the button Round in the top menu bar. First, select 3 edges one after another. Multiple edge selection can be done by pressing the Ctrl key. These 3 edges are selected together. Therefore, they become part of one set. Now, click on the tab Sets. We can see all these 3 edges are listed under Set 1. We can create a new set by clicking on the option New Set here. Since Set 2 is active now, so we click on any edge now, it would become part of Set 2. So, that's how we create sets and control the parameters of multiple edges together instead of doing that individually for each edge. Now, click on OK button to exit from this operation. Now delete the round to perform other operations. To delete this, select the round and then right-click and select the option Delete. Next, we'll learn about Auto Round feature, which can be selected in the drop-down menu of Round button. Now, select an edge. We can change the round radius here. And now press OK. You can notice that all the edges have been rounded off automatically except the one we selected in the beginning. So, we have to exclude the edge from auto round operation by clicking on it. If all the edges are required to be rounded off automatically, we don't have to click on any edge. All we need to do is just provide the radius value. Now, delete the round. Press Ctrl plus D to fit the model into screen. Next, we'll learn to create shell feature. To do this, click on the button labeled as Shell in the top menu bar. Now, select the reference surface for shelling. Reference surface is the one through which shell would be created. Here, we selected top surface, so it would get removed and shell would appear. Now you can see that shell is created with uniform wall thickness all around. This thickness is nothing but the default thickness which can be changed as per the requirement. Please note that all the walls will be of same thickness by default. Now, we'll change the reference surface and see how the shell direction is changing. Now, we'll learn to do the shelling with different wall thicknesses. For this, click on References tab. Here, you can see a column which lists out the non-default thicknesses. So, select the surfaces which have to be of non-default thickness. We have added 2 surfaces here, so the thickness of these walls can be controlled separately. You can input the thickness value in the model itself or at the top, next to the surface ID. Now, you can see the thicknesses are different for these 3 walls. Click on OK to close. Press Ctrl plus D to fit the model into screen. Now, delete all the features so that we can work on other design features. Now we'll be learning to create rib feature. Click on Extrude button on the top. Now, right-click somewhere in graphical area and select the option Define Internal Sketch from pop-up menu. Make the sketching plane parallel to screen by clicking on Sketch View button in Quick Launch area. Now, right-click somewhere in the graphical area and select Construction Centerline from pop-up menu. Now, draw Construction Centerline vertically. Now we'll create some geometry which would be used to create rib feature. Since our area of interest is rib create rather than this geometry, therefore, I'm not getting into details of geometry creation in this session. Now press Ctrl+D to fit the model into screen. Now our geometry is ready to create ribs. So let's go ahead and select the option Profile Ribs from top drop-down menu, which can be found within Rib button. Now switch on the axis, planes and coordinate system. Now we have to select the plane to draw rib profile. We'll create the ribs passing through the center plane of these posts. So we'll choose this plane as a reference for sketching. Now click on Sketch View to make the sketch plane parallel to viewing screen. Right-click and select References from pop-up menu. Now select the two references and close the pop-up window. Now we are all set to draw the sketch for rib profile. Now draw a slanted line as shown here. Define the angle as needed by double-clicking on Angle Dimension. Once done, click on OK. Now you can see a thin rib appears. Thickness of the rib is controlled by this dimension. Rib thickness can be changed from here as well. Now click on OK to complete this step. Press Ctrl+D to fit the model into screen. Now we'll learn to create trajectory rib. For this, click on Rib button on the top and select Trajectory Rib option from drop-down. Now go to Placement and click on Define. Define top surface as sketching plane and leave sketch orientation as default and click on Sketch button to proceed. Click on Sketch View button to orient the sketching plane parallel to viewing plane. Right-click and select References from pop-up menu. The sketch we are going to create is trajectory path for the ribs, which means rib profile has to pass through it. Now define the references to draw the trajectory. Once references are done, close the dialog box. Now create the trajectory for the ribs. We'll have ribs attaching all these rounds, therefore our trajectory must pass through them. We have to delete this portion of sketch as ribs are not required inside the hole. Now, rib trajectory profile is ready. Click on OK button to proceed. Now, the ribs are formed which are all along the trajectory path we drew earlier. Rib thickness and other parameters can be adjusted here. By selecting this, we can add rounds to the rib edges. And this option provides round-on internal edges of the ribs. And this option allows to add draft for plastic and casting parts. Now click on OK to finish. Press Ctrl plus D and save. With this, we have completed the learning session on rounds and ribs. Thank you.
If you have any questions, you can find us on social media. Thanks for tuning in and have a great day.